Okay, so Professor Lee, you can present your presentation now.
Okay. The screen is okay? My slides.
It's okay.
Okay. So good morning, good afternoon, and probably good evening. I'm Professor Xing Li, and thank you very much for giving me this chance to make a presentation. And today's talk is try to make IPv6 only a reality. Actually, I'm writing a book, and this is part of that is from my book. So this is the outline of today's presentation. The first, the trend. Actually, in 2016, the Internet Architecture Board announced and encouraged the IPv6 only. And in the year 2020, under Trump's administration, there is a document saying the US government's network will be switched from dual stack to IPv6 only. And in 2021, from the Chinese government, China sets goals for running single stack IPv6 network by 2030. So that seems the trend from dual stack to IPv6 only. That means at some stage, turn off IPv4, that's a very big thing. So if we take a look of the AP-NIC, IPv6 penetration and development from Jeff Houston, AP-NIC lab, you can see currently the global percentage of the IPv6 is about 30% versus the total users. It's not too bad. However, it is still a long way to reach 100%. So, and on the left, you can see different region, the countries, the IPv6 development. Actually, in our region, India is the top, and even in the global scale, it's the top. However, this is from ICANN's report. The GDP and the IPv6 per head in each economy. So you can see on the left, the developed countries, both the IPv6 and the GDP are very high. And however, for the developing countries and the less developed countries, except for some exceptionals, the average is very low. So that's a big thing. Even if the developed countries and maybe China switch to IPv6 only, however, we need the global internet. We need to keep the connectivity for everyone in the globe. So what's the solution? And that's basically thing. If we take a look at the internet architecture, actually we are in the networking layer, IPv4 and ICMP v4, and we are moving to v4 to v6, both IPv6 and the ICMP v6. So people talk about IPv6 transition. Mainly, actually, there are two methods. On the very left, that's the dual stack. We are very familiar with this model. And on the very right, that's the ternary. We are familiar because originally 6-bone, that's IPv6 over IPv4, and then later some technology doing IPv4 over IPv6. However, either dual stack or ternary cannot give the solution for IPv6 only when there's some internet users or servers still in IPv4. So the only thing we can do is translation. So, however, because IPv4 and IPv6 are not compatible, so translation is not an easy job, because when IPv6, in that case, that's IPNG, is compatibility with v4 is not an issue, okay. However, with the improvement of the translators, we can make the translation transparent. I like also to emphasize the double translation, because if there's something there need really IPv4 headers, then we can do double translation. And double translation is 4 to 6 to 4, similar to turn-in 4 to 6 to 6.4. So actually we can unify the double translation and the turn-in. So that's basically the thing. And the interesting thing is we can have two views for take a look of the translation technology. On the left, that's the network view. Okay, so inside the developed IPv6 only network. However, through the yellow mark, the X-late translation, the outside behavior is dual stack. So even the host is IPv6 only connected to IPv6 only network, but through translation technology, both IPv4 internet and IPv6 internet can be connected. Another thing is more interesting is actually the Android and the iOS from Apple. Both operating systems are integrate translation into the operating systems. So actually to the link, the network links, that's IPv6 only. However, because the built-in translator to the application API, that's dual stack. So both TCP and the UDP have the dual stack behavior. So even, for example, the web page embed IPv4 address as the URLs, still with this double translation technology, no problems. Also, some application embed IPv4 address in the application layer, no problem. So actually, double translation embed into operating system is very good thing. So what's the building blocks for the translation? Actually, everything is standardized in IETF. So if you really want to take a look of, there are two RFCs, RFC 6052, that's for the address translation, and RFC 7915, that's for the header translation, including ICMP and ICMP v6. Also, people familiar with the NET 6.4, that's adding the state maintenance schemes. Also, there are some help or aids. That's the DS64 and the DS46, and try to find the prefix. I will discuss a little bit of these details later. So, however, remember the IPv4 address and the IPv6 address space are very different. So actually, we have to separate servers from the clients. So this is for the IPv6 only servers. We can set up IPv6 only servers on the right. So IPv6 clients on the IPv6 internet can directly access to this IPv6 only server. However, the IPv4 clients in the IPv4 internet can, through the translator provided by the ICP, and translate to IPv6 and still can access to this server. In this case, we need the DS46 because 4 initiate the communication, try to find a record. However, because that's IPv6 only server, there are only AAAA, quad-bore A records. So the DS46 can translate quad-bore A records to A records. And the second is IPv6 only client. So that's the IPv6 only client access or visit to the IPv6 servers directly on the IPv6 internet, or through translator visit the IPv4 servers on the IPv4 internet. In this case, that's the translator's X-late and the IPv6 because IPv6 initiate communication. One thing from the IPv6 only server is we need to share the public IPv4 address as people using NET. Otherwise, we cannot assign each client's a public v4 address, but rather we need the sharing through the TCP UDP ports. Another thing is interesting is double translation. And so we can do double translation, not on the operating system, but like the physical translators. And I will talk a little bit of this in more general examples. So actually, we are on CERNET, we are trying to promoting this not only the solution for IPv6 only server or clients, but to try to integrate into our IPv6 only campus. So that's the idea. The upper stream of the campus is dual stack because we need to both visit or provide services to IPv4 and IPv6 internet. However, on the border router, there is a translator. So the IPv6 only campus can run without any IPv4. And there are DS46 for the servers and the DS64 for the clients, IPv6 only clients. And the inside campus, actually, we have servers. Okay, there is IPv6 missing on the figure. Okay, so can through the translator in the border, as the previous example, can provide services to both v4 and the v6 internet. However, for wired connectivity, because the operating system, there are lots different, for example, even Windows XP, then we need double translation to provide. However, for Wi-Fi, actually, that's interesting. Remember, I mentioned both Android and Apple iOS has the double translation built into operating system. So actually, the Wi-Fi, at least one of the SSID, if the dual stack campus, or IPv6 only campus can be IPv6 only SSIDs. However, there is some difference between Apple and Android systems because Apple, both the iOS and the Mac OS can support the DHCP v6, so can assign in IETF we call translatable address into the clients. However, Android does not support DHCP v6 and only support Slack. So in this case, we need to do additional some kind of net 466 function into that, but that's built in. Actually, that's next 64. Okay, so in addition, actually, if you want only thing provide service, then you can do Slack because Apple also supports Slack. So if you want only a single IPv6 only SSID, then you need to do this Slack assignment through the router AD to get address. However, if you want more control to your clients, then for Apple computers, you can do that. And Windows, that's another story, because Windows currently does not embed double translation into the Windows operating system. So in that case, the Windows system can visit most of the sites, but with embed IPv4 address as the URL or FTP, for example, embed IPv4 address in the application, then actually for those kind of things does not work. Okay, and also actually more interesting, remember in the previous presentation, the CERNET 2 is IPv6 only. So that's already the IPv6 only array. And so, okay, we think the best current practice is with the translation technology, that's okay. The backbone can be IPv6 only. However, the peering and the upper stream through translator use stack. And the users, the campus can be either IPv6 only or double stack. In that case, we need a second translator. And IPv6 only supported VPNs. Remember, I talked double translation. So actually, we can build, for example, RFC 1918's address, for example, number 10 address, and through the public IPv6 internet to build the VPNs. And later, probably, we can even use ULA IPv6 address to NPTv6, which is the experimental RFC published in IETF to do that. And in CERNET, actually, we do both 464 VPN and 666 VPNs. And also, we collaborate with the Beijing city government to try to promote IPv6 exchange points using the translation technology. And later, or finally, if IPv6 only after 10 or 20 years or even 50 years, there will be IPv6 only internet. Through translation technology, actually, the IPv4 address can exist forever because we embed IPv4 into IPv6, so we can still, so the IPv4 is a subset of the IPv6 only internet. That's the idea. Okay, next, some kind of translation. Translation with prefix ISP or the public IPv6 prefix to do translation. So the idea is each ISP can embed your own IPv4 address into IPv6, your own prefix, a subset, a longer prefix of your subset. And others can also do things, but embed public IPv4 address into their own IPv6 prefix. So we can do things independently, but can make the IPv4 communicate without any additional trouble. And the embedding technology is RFC 6052. That's, we can have different IPv6 prefix for providing service. Okay, now what we're doing currently, try to do cross-domain or inter-domain IPv6 things. Okay, in the previous figure, actually, you can see the IPv4, global IPv4 address embedded into IPv6 prefix. However, the IPv6 prefix can be /32, 48, 40, 56, or 64, even 96. So we need to know this information for translation. How to find this prefix? There are three methods already published in RFC through the DNS RFC 7050, through DHCP v6 extensions RFC 7596, or through router advertisement RFC 68781. So there are things. And currently, actually, we are working with China Telecom, try to learn or configure this prefix information through BGP. So if you are interested, actually, we are working in IETF v6 operation working groups, currently in the framework status. So I really encourage or hope the APAN partners, especially in our group, the NOCs, participate in IETF v6 ops. So that's something very interesting. So finally, that's the remarks. I believe, and also like the US government, the Chinese government, and others, IPv6 only is the future. And the second argument is the IPv4 may exist for another couple of decades in the form of subset of IPv6 address. How to link v4 and v6 translation, especially stateless translation technology. There's still a lot of work needs to be done. As I just mentioned, IETF, BGP extension, all those kind of things. And finally, can NRAIS take the lead? Again, we did a lot of things in the development of the internet protocols. And can we also work together on these BGP extensions, and later probably the areas is IPv6 only, or at least we can do some IPv6 only period and provide IPv4 service through this kind of period. And thank you very much.
So thank you very much, Professor Li. Because the time limited, so if the participant have the question or suggestion, you can put it in the chat box, something like that. Okay, so I would like to invite the second speaker, Hirotaka Sato. He Assistant Manager of KDDI Corporation, to present the topic about the APAN-JP updates. So please.
Okay, thank you. Can you see my slides and my voices? Okay. Okay. So I'm gonna start. First, I'd like to share updates APAN-JP as the S7660. And the first, I'd like to update our backbone. So many speakers in past 1 year or so shared how APAN-JP survived during many outage, but we have not shared the current backbone map. And I'd like to explain how the backbone has been evolved in recent years. And actually, the APAN-JP is built on top of the JGN switches in the overseas locations. And so if you're connected to JGN, you have a chance to connect to the APAN-JP as well. So our POP is located in Tokyo, Hong Kong, Singapore, and Bangkok in Thailand. Also, we are connected to the Transpark at Tokyo and ASTI via mapping at the ASTI circuits. In the 2019 February, there were the main pass and 2 backup paths between the Tokyo and Singapore. And the main path is via the JGN Tokyo, Hong Kong, Singapore link. And the second path is the NI's Tokyo, Singapore link. And the third path is between the Hong Kong and Singapore. This path is provided by the KOREN, and when this link is used, the traffic will go to the Seoul from Hong Kong and back to Singapore. And as far as we can tell, the KOREN's backbone between the Singapore and Hong Kong is very resilient. They have fewer maintenance than the JGNs. And however, if we lose Tokyo, Hong Kong circuit from Tokyo, and also the Tokyo-Singapore circuit at the same time, which occurs 1 time in 3 or 4 months, we will lose connectivity to the Southern Asia regions. So that was the very big problem for the couple of years in the past. And when we hear about the Arena Park's Tokyo Guam circuit, and also the consortium, there will be a consortium who is going to build the Singapore Guam link. So we were more than happy. And but around November of 2021, we got maintenance notice from the JGN circuit while the circuit to the Singapore was forced down. So I asked the Asai-san, known as Panda-san, when the Singapore Guam link becomes available, and he told me it's near the final connection. So I talked to the Simon and found I can bring this path be up right before the maintenance. So I sent an email to Francis, also Christian in the Gorex, and the next morning I configured the router in Singapore and Tokyo, and I could save the traffic. So we can save the traffic, but however, the Singapore ground link was being cut like the 3 days after, right after the backup link has been made. But so we lost Singapore reach a bit for a while. So it gave me a lesson. Singapore ground link is not stable as it was between Singapore and Los Angeles back in 2019. Well, so the following months, we reached out to Steve at the ARNET, and if he can provide the backup between the Guam Singapore, and he said yes. So he kindly gave us the backup path across the Australia continent. So we have the third backup in here, Australia. So this is the current backup workable map. So this is the very current the APAN-JP backbone. So as you can see, there no change from the 2021, but it is more resilient than ever because the Signet has deployed the router in Singapore with the AR partnership. So even if we lose all the Asian links go down, we can reach Singapore via the US and the Euro. So the next is the RPK deployment in the APAN-JP. So we have completed the RPK deployment in the on August 5th, 2022. So we are rejecting all invalid routes on every router in APAN-JP. So if you encounter any problem, please let me know. Third topic is GXP-Tokyo, and at APAN-52, we stated that we are running GXP-Tokyo, but there were only 2 international partners, Pacific and Wave and the ASTI at the time. And after 1 year, we have the 4 updates on the GXP-Tokyo. First is the connection to the ASTI, upgraded to 10G via the muffin circuit. And the connection to the muffin has been upgraded from 10 gig to 100G. And also the big news is the PNWJP and the Singaren are now connected to the JPIX, which is the commercial IX, through the GXP-Tokyo, and the international links they have. Also the Pacific does have the also the of course the through the Transfac and through the with the 100G. So we are going to continue to provide more service at the GXP-Tokyo. And the fourth topic is the perfSONAR. Overview of the current APAN-JP perfSONAR is as shown. So we have 2 test nodes. So there's 1 10 gig test point at the Tokyo KDD Otemachi building. Also, we have dedicated delay and loss test points. And we have also host 2 major MaDDash. One is APAN-MaDDash, and second is the GXP MaDDash. And the news is that we are building 100G perfSONAR finally. And due to budget issues, we could not buy the whole server, but we are buying parts like Lego blocks. So we now have a CPU, memory, and the NICs and the transceiver. And CPU is we currently have is the Intel Xeon Gold 5320 with a 26 core at the 2.2 GHz. And memory will be the DDR4 3200 MHz with the 25.6 GB per sec. And NIC is the Mellanox Connect X5 with the LR4 module from the Fiber Store. And currently we don't have box itself, so we are under procurement for the base system. So hopefully this system will start working within this year or at least by spring. And at the TNC 22, we have heard that the GXP MaDDash is in orange. So in the 2021, it was all green, but after that, after 1 or 2 years, it became all orange now. So we've started fixing this starting this month. And actually, we have updated our configuration file to the new format and start sending out mail to all orange perfSONAR nodes. And the progress is being a little bit slow, but due to summary, so but we've got the giant Paris nodes fixed thanks to the Ivan at the Jinan. So we will contact all nodes all over the world to fix this MaDDash. So we hope we can report a nice green grass grid in the next APAN. So the last topic is the P4, which is the new challenge at the APAN-JP. So P4, as many people already are aware, so it's a programming language for the data planes. So it enables decoupling of the data plane and control plane. So on typical switch and routers, as you know, the data plane, the control plane are tightly bound to the hardware. But this architecture itself is fine as long as we have satisfied with the features that the box provides. But when we want to implement new feature of the box, this will make it difficult. So we have to implement from the ground just to add a feature. But we have to deal with the SDK that the chip vendor provides. So to bypass this process and start implementing the feature right away, so P4 acts as a common platform for data plane and use P4 software in the wild to implement the data plane. So that developers can focus on developing the features that they need. So we see, as a APAN-JP, see the P4 as a sandbox environment for the testing proof of concept level ideas. So that'll be the kind of a test bed for us. And there are several implementations for the or model for P4. The most famous P4 implementation is the BMV2, which is for the virtual environment. The second one is the Intel Tofino. Intel Tofino, it was acquired by some company, was acquired by the Intel, and there's actually physical chip available with 12.8 terabits per second, so that there are already 100G switches with Intel Tofino. And also Intel provides the SDE so that we can implement features in both physical and the virtual environment. And why we are so into the P4 is that because of the Jinan. So P4 in Jinan is very active, and they developed a data plane implementation which is called RARE, Router for Academia, Research and Education. So also they deployed a P4 switch across Europe and announced the P4 lab as a testbed with 100G and 10Gs. And some North and South American engineers also joined this testbed as well. And I made a test environment in the APAN-JP servers. So with the Intel Tofino on the virtual platforms. So I have just followed the example set up by Jinan. So I prepared a VMware ESXi environment. So then I made the virtual machine, 3 virtual machine inside. And one VM is for the host for the P4 switch and the router with the Ubuntu 20.04. And 2 VMs act as a computing nodes. So I have set a goal if ping can be reached between 2 computing nodes. So it means ping from host 01 to host 02 will be the goal. And inside the P4, this VM, so there are data planes and the control planes. And on the data plane side, I use the Intel Tofino. And this will act as a P4 switch consisting of the 3 elements. One is a rare P4 Tofino model, which is a data plane itself. And one is called the BF switch D, which runs the P4 model and enables routing. So another one is called BF4.py, which is a Python script, which enables the packet forwarding between the data plane and the control plane through the gRPC. So it is very slow. And also for the control plane, I have placed the free router as a control plane. And the free router is a default choice for the rare environment. Free router is capable of doing the many protocols you can think of, so APAN-JP, OSPF, ISIS, MPLS, EVPN, and others. And I use the PCAP to connect the control plane and the data plane. So all frame will go through the PF or the P.py as a gRPC and received at the PCAP int.binary and forwarded to the free router. So let's get to the demo. So the on the left side, on the left two is the host, and I have launched the free router, and also the we have launched the switch, and these are the tools that I have explained. So the I'm starting the these tools. Then after a few seconds or so, let's wait a moment so that we can. We can ping each other in a few seconds, I guess. So the bottom window, it is running the MAC address also, so it should be in the few seconds. We can see the MAC address being run at the gRPC server. Yeah, that's it. So we can see the ping is going between them. So that's a demo. So the for the next steps, we are going to test this with the real router switches in APAN-JP. So on the free router website, it says that they confirm the interoperability with the Juniper and Cisco. So that just be fun. And also we are planning to test this environment with a physical switch. So I'm trying to get a quote for this H-core wedge 100BF-32X, which has the Intel Tofino. And also if I can test it somewhere else, so we should be good with that. So that's it from APAN-JP NOC. Thank you very much.
Thank you very much for Mr. Sato for the interesting update for the APAN-JP. So we have any, we can have the one question or comment.
Yeah, sure.
Okay. So if no question or comment, so if you have, if the participant have the question, I can put in the chat box. So thank you very much for Mr. Sato.
Thank you very much.
Okay, so I would like to invite the third speaker, Hyunsook Kim, from network operators of the KOREN NOC, Korea. The topic is a KOREN technical update. So you can start your presentation now.
Good afternoon. Can you hear me? Can you hear me?
Yes, I can hear you and I can
Okay.
see your presentation.
Good afternoon.
Yes.
This is Hyunsook Kim from KOREN NOC. I'm very glad to share current KOREN status and the technical updates focusing on a KOREN AI platform. Okay. And here is the contents. I will start my presentation with a brief KOREN introduction and then introduce our KOREN AI platform and its use cases. Finally, share our future plans for the rest of this year. Let's take a brief look on KOREN infrastructure. This is the topology of KOREN. As you can see, we have 10 domestic pubs nationally and 2 international pubs in Hong Kong and Singapore. The domestic backbone is composed of majorly 100 gigabps up to 660 gigabps connections. We plan to upgrade major link from Seoul to Daejeon from 660 gigabps to 1.2 terabps by next year. And this is our international infrastructure. We have two 100 gigabps connections from Seoul, one to Hong Kong, and another one to Singapore independently. And we're going to keep these two international links until 2023. If you need any backup between Hong Kong and Singapore, please contact us in any time. The KOREN T-SDN architecture is shown in this slide. We have operate the open daylight-based T-SDN controller and manage the optical transmission devices. The devices are ROADM and POTN. All of them are developed by our domestic company, Koiber and Urinet. This is traditional open flow based IP-SDN of KOREN. As you can see in this figure, 5 domains are organized in a hierarchy manner and under one main controller. And they are 2 controllers in each domain. Once master controllers fail, the other will be automatically changed. Due to the demand of various experimental environments from the researchers, we developed new IP-SDN based on ConnectConf protocol last year. So the architecture is following the global data center standard, data center architecture, spine leaf architecture. So spine switch is connected or interconnected, or if all leaf switches in full mesh topology. We are using open daylight SDN controller, and the controller application is under development. And so far, we have been talking about the current KOREN physical update. Let's move to today's main topic, KOREN AI platform. KOREN has worked hard on AI research over the past 2 years to build this AI platform. As you know, AI is a very popular technology. The fields where the deep learning AI technology is applied are dramatically increasing, such as smart factory. So KOREN has been continuously striving to apply AI to entire KOREN infrastructure since 2020. We are focusing on the anomaly detection, network failure prediction, something like that. So this figure shows the concept of the AI platform. We are focusing on helping how to help the AI network operators to find out the root cause and preventing failures in advance. So collecting all data from the KOREN infrastructure and send to the integrated data lake, and then such as performance log and traffic data. And then AI engine analysis overall data and help operators to find out the root cause of the failure by providing the exact failure point and the related history operation guides. This is the roadmap. You can see how KOREN moved towards AI since 2020 to 2023. So in the past 2 years, we have complete hardware installation and start collecting the data from the infrastructure. So this year, we are going to focus on the data analysis and engine development. Finally, we are going to achieve some function of AI-based network failure prevention, self-healing, and self-configuring next year. Here is the overall system architecture. The KOREN platform consists of 3 components: SDI control domain, integrated data lake, and AI platform. The final goal of this system is to achieving the closed loop control loop between these 3 components, enable automatic infrastructure operation without network operator interventions. SDI infra status data delivered to the data lake, integrated data lake. The data lake stores not only raw data, but also pre-processed standardized data. And then the processed data will be fed to the AI engines to perform anomaly detection, prediction, and classifications. According to the AI analysis result or decision, it will be translated to the network commands to the SDN controller to configure the target devices. So the change network infra status data will be retransmitted to the data lake, something like that. So because the KOREN SDI and integrated data lake have been introduced several times in past APAN, so I'm going to skip these 2 in this presentation, and I will focusing on AI platform. Our AI platform consists of 2 parts: AI-based KOREN NMS and the AI engines, a group of AI engines. So let's look through one by one. So first, AI-based NMS. This NMS covers KOREN overall networks, both IP-SDN and T-SDN, kind of integrated monitoring system of KOREN. So from 2020, the AI-based KOREN NMS is developed. The monitoring target devices are ROADM, POTN, and white box switches. So the AI models are used for both T-SDN and IP-SDN in different way. For T-SDN, AI is used to detecting the optical signal anomaly. The anomaly is detected when in the optical communication, it is suggest an alternative path to the operator. The link is failed. So it is very useful. The link remains in weak and not completely down. In IP-SDN, AI is used to detect anomaly traffic for network failure prevention. The biggest change to another NMS is the biggest difference of this NMS is it has a AI model monitoring function. If we want to use AI-based anomaly detection, it will be monitor the AI model itself too. So AI are running. We should continuously monitoring that the AI models are running well. Then how the number of AI models are in action, and the prediction accuracy trends and the distributions and so on. So this function is one of the key functions of our AI-based KOREN NMS. Basically, AI model updates itself per 3 months to reflect users' recent traffic users pattern in prediction result of AI model. However, if operators detect that prediction accuracy has been decreased, then operator can manually initiate the retraining process. From now on, I'm going to explain how this abnormal traffic engine, AI engine, is developed in terms of data and its processing. We use autoencoder-based anomaly detection model for endpoint users traffic predictions. One model for one user. So as you know, but we are very difficult to obtain the abnormal traffic data. So anomaly detection AI model used to usually learn the normal traffic and predict future traffic by identifying the periodically attract the normal traffic data as a training low base, and pre-processing for the data set. We process recent 2-hour data so that if can be used as an input. And so the AI model classified as an abnormal when executive or under traffic with low probability of occurrence. Our AI model are based on 1D convolution architecture. We did a performance evaluation for our AI model. The data 1 and 2 is Yonsei University and the Jeju Energy Corporation reactively from the March 10th and July 20th in last year. We found that the 1D convolution model, it shows relatively high accuracy and fast computation time, fast computation. So as you can see this graph, the blue line is the measured value, the yellow line is the predicted value. From now on, I'm going to share the use case, but due to the small extent, we couldn't use AI servers from last December to the April this year, nearly for 5 months. So actually, we started use this AI NMS around June. So even very short time of our operation, but we can share 2 cases for AI NMS use. First case is the AI anomaly detection. We found that the AI model can detect very well for these 3 kind of abnormal traffic, like traffic usage. They will send travel tickets when these 3 traffic users is detected. One is like a steadily rising or suddenly decreasing, or periodically pops up. They will send the travel ticket with brief information contains the time, node, port number, and user names. Operators can give the feedback to the AI prediction result in form of match or mismatch. Because the time is very short, so so far I don't have any, I have not experienced any real abnormal traffic detection, but I think it will be possible in the future. This provided operator provide the feedback. The provided feedback data will be correct the label of the data, and then model learns the corrected data during the scheduled retraining process. As you can see in the graph at the bottom right of the slide, after providing feedback for 6 weeks, we can see that AI prediction accuracy is continuously improving slightly. And here is another use purpose in another way to use AI-based anomaly detection function. These three graphs shows in traffic ticket when anomaly traffic is detected from NMS. The purple bar indicates the time of the anomaly detected. So the NMS sending the trouble ticket when some users start to use network suddenly, like this Pangyobundang Seoul National University Hospital or Gyeonggi University. And we can detect the traffic uses of user without having to check them one by one. So then third graph is Yumitech. It is a startup company that predictably transmit the certain amount of traffic to measure the network performance. So so in conclusion, we can get a very useful information. It can provide a good information to us when some organizers use traffic, particularly in high volume. And the second use case is root cause analysis. On the last July 18th, there was a module replacement in Daejeon POP ROADM device. This module is used to connect Daejeon and the Gwangju optical link. So the AI NMS shows the exact failure point and the related alarm logs directly, which is directly related to the failure. So also we can check the log with the highest priority first. So it was very useful and helpful. In summary, we a lesson learned in two use cases. The first point is many facilities and operated by the operators know-how and highly rely on the operators know-how and manual work, but it has been changed to automation. And the second one is when the network failure is occurred, we can see the intensive logs analysis for the root failure analysis. And finally, we found that the manage point has been changed. We have to monitor AI model as well. So we spend many time on AI monitoring and providing some feedbacks. And also takes some time to find out when travel ticket is generated, the result is correct, is real or not. So something there is a drawback anyway. And so from now on, I will start share our future plans for rest of the year and conclude my presentation. Although it is very short time, we would like to upgrade three functions based on the operation experience. First is according to the operation experience, the backbone and the end user has very different traffic user pattern. So we should put them into different categories before the prediction. The second is the self-optimization function. We will be in IP-SDN network, developed a route recommendation function, path, suggest path. So for example, abnormal traffic occurs, then the suggest best route, which is to the optimized path. When the operator is confirmed, it will be switched to the suggest path. and we'll continue to collecting the operation data, and then we have to upgrade the self-healing process, focusing on the filtering out useless travel ticket to achieve auto recovery from these unfailure alarms. So anyway, it's too much traffic ticket, so we have to filtering them by AI or other solutions. And here is new approach in traffic anomaly data, traffic anomaly detection. Because autoencoder based on anomaly, autoencoder based anomaly detection has some limitations on like text very similar to normal detection of normal traffic. So we think we have to add some classification, like classification process just before the prediction. So find a cluster of endpoint users by their traffic records and build a common model for each cluster. And the cluster-wide cluster-wide model will be predict for all endpoint users in this cluster. The goal is to detect detect the anomaly that are very similar to normal traffic usage pattern. Our existing AI model.
Your presentation time is time out.
Oh, okay.
So please
I will conclude in 1 minute.
Okay, thank you.
Existing AI model works very well in end user, but which have steady traffic users. But in nature of the research network, we have a lot of normal traffic, which contains the abnormal patterns and features. So we decide to use this AD US AD normally two-phase training, which USAD algorithm to our AI model, which is published in KDD 2020. So the main idea is to place one more decoder to perform the adversarial training. The goal is to detect, as I explained before, detect anomaly that are very similar to normal traffic usage patterns. This is all for my presentation. Thank you.
Thank you very much. The next speaker is Ryan Im, technical consultant of the HKIX Hong Kong. The topic is HKIX development and HKIX R&E updates at the APAN-54. So you can start your presentation now. Okay, please show your presentation. Okay, thank you. So you can start now.
Hi, good morning, everyone. My name is Ryan, and today I will give a quick update about HKIX developments and R&E status. Let me introduce the background of HKIX, and it is established in April 1995, and it is a main layer 2 internet exchange point in Hong Kong. And HKIX is now owned and operated by Hong Kong Internet Exchange Limited in cooperation with Information Technology Service Center of CUHK. And we are serving both commercial network and research and education networks. And our goal is to keep intra-Hong Kong traffic within Hong Kong. And here is our new architecture from 2021. And this is the simple diagram of our network. And you can find in our website. And today we are supporting both multilateral and bilateral peering over layer 2. And we also support V4, V6 dual stack. We also observe that there are more and more non-Hong Kong participants connect with us, and we have 340 plus different network connected, and there are 550 plus physical connections in total. And 117 is 100 gig, 310 is 10 gig, and 110 is GE. And our total traffic at peak is at 2.29 Tbps, and our annual growth is around 330. And this is the daily graph in 5-minute FH. And this is the yearly graph in 1-day FH. In this diagram, you can see the trend of 100 gig connection at HKIX until June of 2022. We have 117 100 gig connected. And here is the 100 gig participant list. And you can see they come from different industries, such as a content provider, regional ISP, local ISP, retail and gaming, NTT DOS provider, data center, and others. Apart from that, we have multi-sector sites, and it allows participants to connect HKIX more easily at low cost with cost connect from those sectors in Hong Kong. And it also cooperate with multi-data center in Hong Kong, and it can maintain the neutrality, which is the key success factor of HKIX. And this model can create a win-win situation with sector site cooperators. And we have 5 sector site, which is called HKIX 1 to 6. And you have to remember that HKIX 1 and 1 boy is our core site within campus, and 1C is the new core site at Cyberport. Also, we have the reseller program. It is to provide one-stop shop service by HKIX resellers. And this program is non-exclusive arrangement. The reseller can be ISPs, data center, local and regional ISPs. And in this program, it supports a share port mode or a dedicated port mode. In the first patch of a reseller is allowed to connect sector site only, but they can connect our core sites now. So if you are interested, you can contact us for the reseller program. Other than that, we also support the R&E networks, and we are helping those R&E network interconnect among themselves with commercial network without restrictions through our switch and MegaEye. And our purpose is to facilitate those national R&E networks have presence in Hong Kong to do interconnection among themselves and do peering with commercial network. And there is some background about HKIX R&E network. And it is started in 2008, and it is free of charge to R&E participants and connect to our commercial network. and it is support GE 10G 100GE trunk link. And in the technical side, we support point-to-point VLANs, jumbo frames, but you have to aware that the fiber cross connect in MaDDash should be provided by the R&E networks. And also we have offer R&E equipment co-location at HKIX or CUHK. And the whole R&E network is operated by HKIX. And there is the network diagram about R&E. And here is the VLAN assignments for each R&E participants. For our R&E upgrade, actually we have complete the upgrade for the backbone between MaDDash to our HKIX core site to 1T in Q4 2021. And here is the R&E connection at MaDDash. In this diagram, you can see our switch is located at MaDDash, and the MRAN connection is connected to this switch. And we have 100 gig links go back to the our commercial network. That means the core site. Here is our planned works for 2020 and 23, and there are some projects which is working in progress, such as we are looking for 400 gig port to support in core site, and we will do some enhancement for our existing portal, deploy a new open source file server, set up an NTP server in HKIX community, and we are working on the DWDM and dark fiber deployments between core sites. And the more important one should be HKIX1 migration, because we are our HKIX1 will be decommissioned in the future. So we are going to planning some port relocations from HKIX1 to HKIX1 Boy or 1C. And the last ones, we will deploy more Ocala speed test nodes at HKIX1C. For the security improvements, we are working on the Security Operations Center. For the R&E upgrade plan, we are looking for the 400 gig connections, and also we are looking for the software or hardware to do more network traffic visibility and network automation with multi-vendor supports. And here is our VXLAN EVPN deployment. We would like to share some experience with you, and you can see we have VXLAN in HKIX1C, and we also have the fabric path in HKIX1 and 1 Boy. Between both network infrastructure, and there are some border leaf connecting these two networks together. And in this deployment, we are facing some technical issue, and we would like to share some real case to you. And you can, in this diagram, you can see the ISP-A is connecting with VXLAN, and ISP-B is connecting with fabric path, and both interface is port security enabled, but somehow ISP-B interface has loopback traffic source from ISP-A. In this situation, we found that in the data ping level, the traffic should be dropped by the port security, but we observed that there are some issue on control ping. The first problem is fabric path switch port security is on, but it cannot prevent its MAC learning. And the second one is the VXLAN border leaf switch will not correct its CAM table when the loop traffic stopped it. And here is the syslog message in our border leaf switch. And we have found some workaround, and we are using EM script at VXLAN border leaf switch to run below command when detect the syslog message. And this command can help the VXLAN border leaf to get the latest MAC address information. And also we have opened the tech case with the equipment vendor, and they offer the solutions is to release the OS and will correct the CAM table when the loop traffic stopped it. And here is our information for your reference. And this is all of my presentation. Thank you.
So thank you very much.
Yeah, thank you, Dr. Panjai.
Okay, so the last presentation is from the Steve Li, Fresh Pang, and Lian Chan. Steve Li is senior specialist from the Hong Kong University of Science and Technology, and Fresh Pang and Lian Chan is from the Education University of Hong Kong. So the topic is a Hong Kong Academic and Research Network HARNET R&D node updates. Please start your presentation.
Okay, good afternoon, everyone. My name is Steve Li. I'm Senior IT Specialist of the Hong Kong University of Science and Technology. Today, I'm glad to be representing JUCC HARNET to provide HARNET R&D notes updates in APAN 54. Here is HARNET R&D note background. Previously, HARNET R&D note is called HKOX, Hong Kong Open Exchange. It is formed in November 2016. The mission of R&D note are to facilitate data exchange between Hong Kong and overseas institutions, to increase collaboration and achieve resources sharing between the global R&D community. At the second part of my presentation, I will show some of the projects that Hong Kong institutions leverage HARNET R&D note to collaborate with global R&D community. In addition, Hong Kong government is one of our funding source to support our ongoing development. Our R&D node is located in Hong Kong Mega I Advantage Tier 3 data center. Everyone are welcome to connect to HARNET R&D node so that both Hong Kong and overseas researchers can work with their counterparts efficiently. Everyone can decide the bilateral or multilateral peering models. Here is the R&D node infrastructure. It is a Juniper MX10003 model. It can support 1 GE, 10 GE, and even 100 GE interface. HARNET RNG nodes joins perfSONAR, which provides performance monitoring for researchers. And our AS number is 137207. This is the high-level topology of HARNET infrastructures. It consists of two parts. The left-hand side is the HARNET RNG nodes that connected to different NRAN, cloud service provider, and other content providers. The right-hand side is the HARNET network that connected to most of the Hong Kong major institutions and the Hong Kong Internet Exchange, HKIX, to support the high bandwidth demand of research activities. We planned to upgrade from 210 GE links here to 200 gig links between HARNET RNG nodes and the HARNET network for Hong Kong institutions. It would be ready by September 22. Actually, it is end of next month. Recently, we have participated the APNIC ISIF funding project on developing a collaborative BGP routing, analyzing, and diagnosing platform. The objectives are to establish a distributed BGP routing monitoring platform in Asia-Pac region, to provide a looking glass platform, monitor BGP routing change, analyzes the robustness of routing in Asia-Pac region. You may access the link highlighted in here. The portal can provide not only the HARNET RNG node to different NRAN routing path information, but also provide the HARNET RNG node to public internet path information and the IPv4 and IPv6 prefix information here. It provides a single pane of glass to analyze the RNG node routing information using this single portal. At 2021 September, we have joined the partnership with Xing Li and NICT for 10-year cost sharing for the 100 gig circuit. 4 parties MOU was signed in December 2021. In addition, JUCC was invited by Xing Li to join AER in September 2021 and signed the MOU during last APAN 53 in March 2022, which is around a few months ago. Last year, Xing Li invited JUCC to join APO-NET in October 2021 and signed the MOU with APO-NET in January 2022. Also, we signed the MOU with CERNET in November 2021 as well. You can see a lot of activities since last year to the Q1 in this year. For now, we have established peering with Asia Connect, NICT, Xing Li, KoreanNet, CERNET, and CERNET2. For the public cloud provider, we have peering with Google, Apple, Amazon as well. As mentioned before, JUCC renamed it to HARNET RNG node in 2021 officially. JUCC established a 100 gig peering connection with CERNET2 in early 2021. In order to provide better latency and user experience of using Microsoft Cloud Service, we plan to establish Microsoft Express Route in coming future. As mentioned, we are welcome NRAN to connect connect to HARNET RNG node. Two types of connections are supported by HARNET RNG node. By default, all new NRAN join the RNG node with the layer 3 service, and all routes will be sent to all peering partners. Another types of connection is layer 2, that is dedicated point-to-point VLAN connection with NRAN. Here is some of the projects that leverage HARNET RNG node for the research activities. For this project, a huge amount of data from periscope, drone, and PhenoCam data sharing between the researcher in ecological and environmental science by School of Biological Science in University of Hong Kong. As you can see here in the table, around 200 high-resolution drone image, it generates around 1.6 TB data already. This research topic is to understand the pattern and the drivers of climate change and how it impacts our natural ecosystem by University of Hong Kong. HARNET RNG node is supporting this Earth's environmental monitoring project with this high amount of data sharing continuously. The HKUST and MIT Alliance aim to build a network and mechanism required for R&D collaboration between world-class universities and technology companies to bolster the global innovation with emphasis on intelligence living technology. HARNET RNG node play a role to support those university and technology companies' research activities on IoT, data science, and e-learning research, advanced manufacturing, and biological system. Another project here is mining the antibiotics resistant genes by University of Hong Kong. The objectives of this project is to investigate the global distribution of different antibiotics resistant genes and study their evolution and emergency. The research is using genomic data set from US data bank from the University of Chicago. Another project from Chinese University of Hong Kong and CERN. CERN is the European Organization for Nuclear Research. This project is to enable CUHK physics students and scientists to participate the research in experimental particle physics. CUHK set up a HPC cluster linking with CERN HPC cluster right on HARNET RNG nodes for physics calculation and analytics. Another project is the machine learning analysis to improve the low energy sensitivity of major atmospheric gamma imaging Cherenkov telescope called MAGIC. The MAGIC gamma ray telescope work by detecting flash of Cherenkov light produced in the atmosphere. Every 60 hours, over 30 TB telescope data have been taken for this project. These data will be transferred from the UAB Barcelona to the University of Hong Kong. As you can see, there is a lot of research activity daily in HARNET RNG node. Here is the recent overall traffic of HARNET RNG node. The peak is starting at September, which is always the new semester for most of the university in Hong Kong. The peak is around 20 to 23 gigabit per second. This is our website for information sharing of HARNET R&D nodes. For recent update, please feel free to check it here and contact us. By the way, we are welcome to join us in the website. You can submit the e-form to leave your contact information for the application. Thank you, everyone. That is the end of my quick update for the HARNET R&D node. Thank you.
So thank you very much for your nice presentation. So I think the time is out. Does Konishi-san has any comment or suggestion for this session? Konishi-san.
Hi, thank you very much for the presentations. I personally learned a lot from your presentations, especially for, AI-driven one or, HKIX and Sato-san's P4 languages or something like that. Thank you very much. I personally learned a lot, and probably you can also enjoy the presentations this afternoon. Thank you very much.
Okay, thank you very much, Kunichi-san, and thank you very much for all speaker and our presentation, the nice presentation, and thank you for all participants too. So I would like to close this session and see you again soon. Thank you very much.